Assalamualaikum and good days. For this test, the objective of this test is to assess the structural integrity of a basketball hoop assembly comprising a backboard and rim made of alloy steel under the applied external load of player hanging on from the hoop, which is 80 kilogram, and to provide design recommendation based on maximum stress and displacement analysis. Okay, this is the design of the basketball hoop that will be used in this test. So this test is require a simulation process. So we need to activate the simulation tab. Let's click on the new study. And I will just name this to code analysis. And we create okay. So the design tree for the simulation will come up. Okay. All right. The next one is to define the parts. Right click on the parts and apply volume measure to all. And we select cast alloy steel, which is to follow the requirement of the test. And next, right click on the fixture and click on fix geometry. And add this edge vertex for feature color. We need to select the surface. So this place we will select the backboard of the basketball court. So we just click on the surface and click on OK. Okay, next one. To set the contact set on the connection, right click and click the local interaction. Alright, for the start, we will just stay on the contact, and the face for asset one, we will select this face. And face for the set two, firstly, open the design tree and add the backboard component. So it will reveal the face for the basketball ring hook. Then we select this face for set two. Then I hide the back. And click on OK. And for the next one is to define for the force loop. Click on external load and click on force. For the endpoint of the force, we will select at this point and click on it. And click on selected direction. And the plane for direction, I will choose the right plane. Next, I'll set the unit to English IPS and click on long plane direction group. So this place we need to enter the external load, which is empty kilogram, but the option given is in LBF, so we need to convert 80 kilogram to LBF, which is 176.137 LBF. And you need to click on reverse direction. And then click OK. Next is to define nut bolt connection. So on the connection, click on bolt. So we choose standard or contour with nut, and the circular edge of the double head hole, click on this. And as for the bolt nut hole, click on the opposite. As on the diameter, I'll change it to inches, and I set it to 0.75 inch. Same goes to the diameter. And for the material, I've set it to custom. Since I've chosen English APS before, I'll keep on using English APS on the other specification. And goes to the period, click on Excel. Yeah, 0, I'll set to area. Apply on the box on the other folder. and click on Run this study. And the stress is up. Click on the definition. And I will change the value of this uh, stress into PSI. The chat option and number format, I will keep on floating. Which is like this. This is the result of the displacement on the basketball hoop. Uh, this displacement analysis shows the basketball hoop's deformation and the 80 kilogram load. Uh, the maximum deflection is at the rim's front edge, which is the part where the red zone appear. So for the deformation pattern, uh, at the mounting bracket, it has a minimal movement, which is it is properly constrained. As we can see, it only has a blue color appear. And next is the limb progression is the deflection increase from back to the front. And in the critical area is the front portion of rim, which is it shows the accessory bending. So the functional impact for this displacement, the deflection is too large for basketball gameplay. In the standard requirement is under 5 millimeter maximum deflection. Right now the deflection appear is uh, 14.63 millimeter. So it is too much gap for the from the maximum deflection required. So this current design fails both structural and functional criteria. So for the simple conclusion, for this basketball hoop, the rim bends so much under the load, which is it is unsafe and unusable for basketball game. Due to the large gap between the actual uh, actual deflection distance of deflection and the minimal safety requirement for the deflection, which is under 5 millimeter, and the actual is, as you can see here, at the red zone, it become around 14.63 millimeter, which will significantly affect ball bounce and player safety. So this confirms the design is measures threatening to reduce deflection to acceptable levels. As you can see here, the color gradient clearly shows how the rim progressively bends more towards the loading point, with the mounting area blue staying stable while the rim edge red experiencing critical deflection. And next, as for the recommendation to make it become usable and safe to be used for basketball game is to increase the rim diameter from the current size to around 25 to 30 millimeter solid steel carbon, solid steel rod. Also, we can add reinforcement bracket underneath the rim at um, or make it a triangular reinforcement so it will be a better support rather than this kind of 2 point support, 1 point support here, which is quite unsafe. 2 point, which is here and here. Maybe we can make it triangular. And as for the structural improvement, uh, maybe we can reduce the deflection target from 14.63 millimeter to lower than 5 millimeter maximum by adding support rib, by connecting the rim to the mounting bracket with more suitable support rib. Implement by also by implement thicker mounting plate, yeah, and use multiple mounting point instead of single connection. Maybe we can make it a wider mounting plate rather than one focus area here. So for the recommendation of the design, um, we can conclude that one thing of that we can do to make it uh, usable or more safe for basketball game is by reinforce the joint, which is the connection between the rim and the backboard, which is critical. Um, One of the recommendation can be done is by using welded gusset or triangular support, uh, which can help distribute the load more evenly. Uh, for the next one is by using a thicker rim tubing, a larger diameter or thicker for the rim tube will increase moment of inertia, reducing both stress and deflection. And as for the next one is can add support bracket, which is a diagonal bracing from the rim to the board, maybe around here, yeah, which can reduce the effective cantilever length and can lowering the stress. Also, the main part is the material optimization. Maybe we can use a better material, uh, which is more strength and durable. Alloy steel is suitable, but if weight is concerned, we can consider high strength aluminum with similar yield strength and reduced mass. That's all for me. Thank you. So this is the result of the simulation.